What's up, everyone? Today we are going to talk about analyzing lines of best fit. So, last time we were together, we talked about scatter plots and a line of fit. Today, we're going to get a little more technical with it, and we're going to look at specific kinds of lines of best fit, how we can calculate them really precisely, and how to use them to make predictions. So if we want to find a more precise line of fit to model a set of data, we can use calculators to perform a method called linear regression. So let's consider the following. Let's say we want to compare hours on social media with hours of sleep. So I have the hours of social media for 7 individuals here as my X and their corresponding hours of sleep as the Y. Now I'm going to talk about how to do this on a TI-84 or similar calculator, but then I'm going to show you how to do it on Desmos as well. So the TI calculator is what a lot of people in my region do use and in my sphere of talking about math. But I know it's expensive, and Desmos, a lot of people are moving towards Desmos, and it's free, so that's what I'm going to show you here. So the first thing that you're going to do, I've even numbered my pictures, is we're going to take this data and we're going to enter it into lists. So in your calculator, you'll press the buttons, the stat and edit, and then you'll put the X values in the L1 and the Y values in L2. So to clear those, if you kind of arrow up to the top and you click clear enter, it will clear out the whole list so you don't have to delete them all one by one. And then this is a good spot to just double check before you move on that you put all your data in correctly, and then we're good to go. So I'm going to show you what that looks like to put that data into Desmos because it'll be different. So I'm going to click this plus sign here, and I'm going to add a table, and it's automatically going to say X and Y. So then I'm going to start 1, enter 2, enter, and then it's going to start predicting, since I did just go with 1, 2, 3, 4, 5, 6, 7, what I want, and then I'll just type in my Y values. So 9, 8.5, 7.5, 6.5, 6, and 5.5. All right, and you can of course change the color to, yeah. Anywho, there you go. That's my scatter plot. All right, then I moved that over. All right, so now to set up to do a lot more work with the Desmos, it's already right there for me. So you would hit y equals. Y equals is where you would normally type in like equations when you're graphing. And then you have to make sure the settings look nice. So if you have the kind where you can change the color, you can change it to whatever you want. Navy blue is my favorite color, so that's what mine's always set to. And make sure your plot is on. We want it to look like a scatter plot, which is the first type. You can change the marks to anything. I just leave mine as a dot or that square. All right, and then we hit zoom 9, which will zoom your window in automatically towards the statistics. Now with Desmos, I can just pinch and zoom to my data, or use the buttons here, or even if I hit the wrench, I can manually change my axes. So yeah, there you go. All right, now to run the actual regression, you would hit the stat button again, and then you would have to take the right arrow over to calc, option 4, linear regression, which is the screen you'll see here first. It's going to auto-populate that you would want L1 and L2 as your X and Y's respectively. You leave frequency list blank, and then under store regu, if you press alpha trace, then it will store that variable in Y1 for you. Just hit enter on Y1. And so when you run the regression, this is what you're going to get, right? That ax plus b is your linear regression in slope-intercept form. And then it tells you a, your slope, and b, your y-intercept. And then r squared and r we'll talk about later on in Algebra 2 and if you take statistics. But r is the correlation coefficient, in case you need to know that. And 5 is what this looks like graphically. So you have the scatter plot marked by those squares, and then that blue line is the line of best fit that we calculated with the linear regression. All right, so how to do this on my dome is way simpler. So I'm going to click the arrows here to bring my keys back up, and then when I press this button here, it pulls up the linear regression. You'll notice that I get the same values, rounded a little bit differently, from my TI that I got from Desmos, right? They're both very reliable calculators. But here it just puts it into the equation for me, which I think is so nice, right? So the first thing that they'll probably ask what is that equation, right? So here we go. Y is equal to 0 point, I think 2 decimal places, so I'll put 0.59 x plus 9.5. I'm going to move Desmos away for a minute. We want to know a couple about our data here. So what does the slope tell us about the context? So remember, slope, or in this case, the calculator calls it A, is the change in your y's over the change in your x's. So something like negative 0.59, you can think about that as negative 0.959 over 1. I know, ew, doesn't exactly look how we would normally write a fraction, but it helps us think about as there's a change of positive 1 in the bottom, or with my x's, there's a change of negative 0.59 in the top with my y's. So for every 1 hour increase, or let's say additional time, come on, scribble, erase. Every 1 hour additional 1 hour spent on social media hours of sleep typically decreases, because it's going down, or you can say tends to decrease by about 0.59 hours. So like a little over half an hour. All right, now what does the y-intercept tell us about the context? So again, our y-intercept here was that 9.5, okay? And remember that happens, a y-intercept happens when x is 0. So that's telling us a person who spends about 0 hours on social media sleeps about 9.5 hours. And then how many hours of sleep, right? So this is the output, the y, would you expect to get if someone spent 4 hours, that's our x, on social media. So let's plug that in. So I've got negative 0.59 times 4.5 plus that 9.5. I got out about 6.85 hours of sleep when I plug that into my calculator. All right, so let's do another example where we're just the whole shebang all the way through. We're going to run the regression. We're going to make the scatter plot. We're going to answer some questions about this in context. So consider the data below on number of text messages sent, X, and the phone battery percentage, Y. All right, so first we're going to find the line of best fit. So again, how we do this, Desmos here, my notes on the left. I'm going to add a table. All right, and then I'm just going to start chugging away at my data. And again, it notices a pattern, which is cool. You won't always have evenly spaced data, but if you do, it picks up on that, which is really exciting. And then you just take a moment, double check your data. 95, 30, 88, 50, 82, 70, 75, 90, 65, 110, 55, 130, 48. Cool. Now let's find the line of best fit. So again, with Desmos, I'm just clicking a button, y'all. So there you have it. All right, and so my line of best fit is all right. See what's going on. So if someone's 45 text, right, so it says the X, what would you expect their phone battery to be, or what would the output be that you expect? So we would take Y is equal to negative 0.4 times 45, since we're putting that in for X, plus 100.57. And I got about 82.57%. So around 83% would be their battery, we think, if that's how many texts that they've sent. All right. Now, what about the other way? So if someone has a phone battery of 70%, right, this is the Y, how many texts do you estimate that they've sent? So we would say 70 is equal to negative 0.4x plus 100.57. So first we would subtract 100.57 from both sides. Then we would have negative 30.57 is equal to negative 0.4x. So then we divide both sides by negative 0.4, excuse me, and we get out 76, or about, I should use the squiggly guy, 76.43 texts. So we expect them to have sent about 76.4 texts. All right, so we get to talk about context, which, as in statistics teacher, right? I'm like, this is the most important part, right? So what is going on here? So this slope, remember, it's a negative 0.4. Okay, so this slope says that for every additional, I always think about one increase in whatever the axis is. So for every additional text sent, phone battery decreases by about, or tends to, excuse me, by about 0.4%. right, now my favorite question is this last one here. What does the y-intercept tell us about the line of fit? So remember, this will be the 0.0, 100.57. So after sending, or before sending any text, after sending 0 text, however you want to word that. A phone's battery would be about 100.57%. Hopefully that makes you stop and think, what? All right, so what's going on here is that linear regression doesn't always make sense on a y-intercept. Especially when you're talking about like think time, sometimes it doesn't always make sense. So it's something you're gonna have to look for, right? They're not always a perfect system. All right, so there you have it. Analyzing lines of best fit and running your own linear regression, either in a TI or on Desmos.